These key fobs that we have in front of us here are for the old Citroen Saxo, Picasso, Xsara and Berlingo. I made a video previously where I explained to you that these key fobs, they suffer from an RF chip failure. And if that happens, the key will no longer emit an RF signal. I showed you how to source those chips and I showed you how to replace them. Well, this video is going to be a lot more in-depth because we've learned some new information and we want to share some other information that you possibly won't find out there in the internet. So, as I say, it's going to be quite in-depth, though I do recommend you watch it till the end. If you're working on one of these key fobs, then the information that you're going to gain from this video is going to be essential for your repair. Okay, so here goes. This key fob here, this one is a working one that we have in the office. And this one here was sent in recently by a customer. And what they said was that they're working on refurbishing a Citroen. They've got a key fob which doesn't, they bought an RF tester like we showed in the video, and they found that the key fob was not emitting an RF signal. So they watched our video and they contacted us and they said, look, you know, we believe that we've watched your video and we believe that the RF chip on the key fob may be faulty. So please, could you have a look at it and if needed, could you change it out? So what happened was the key fob came in, and I just want to show you that this key fob here, you can see that it's giving off a signal in the 433 MHz range. If I press the other button, that is also giving off a signal in the 433 MHz range. So that key works, that fob works. We can confirm that. And if we then take the other fob, the one that was sent in, you can see here that it doesn't give off any kind of signal when I press the buttons. And I've tested the battery inside. It's at 3.2 volts, which is fine, enough to power the fob, but as you can see, there's nothing coming off it. So this fob came in for repair, and we ran the usual tests that you normally would, and we couldn't find anything unusual from the diode tests that we did. And then what we did was, well, I'm going to open it up now and I'm going to explain to you what we did on the chip. Right, let's open that up. You can see here the chips inside there. I'm just going to get that out the fob so I can demonstrate to you a bit more in detail. So if you have a look here, this is the internals of the key fob, and there are only a few components on here. I'm going to go under the microscope and show you those components in detail. But if you have a look here on the back, right, these are the main two ICs on this board. This one here, okay, is the RF IC, which we sourced and replaced in a previous video, and that got the key to emit an RF signal. This one here is called 64006 IC, and that one is responsible for storing the code for the central locking. Okay, so when this fob came in, we did all the tests, and none of the readings were different from a working key. So just by taking diode mode readings, you would not be able to figure out that there is anything wrong with any of the components on this particular fob, right? So the next thing that I did was I thought, okay, I've seen this situation before where you take the readings and you can't really tell that anything's wrong with it. And from the previous order that I made for these ICs, I've got quite a few of these ICs in stock. So what we did was we removed the RF IC, which is this one here, and we replaced it with a new one. We put it on the RF tester. Where's the RF tester gone? We put it on the RF tester, and it still was not emitting an RF signal. Now, because I've got quite a few of these ICs in stock, I changed the IC out 2 to 3 times with the fresh ICs, and it was still not emitting an RF signal. Because I had a fully working key in the shop or the office, I thought the only thing that is left to check now is the IC next to it, which is the IC that stores the central locking code. So this IC here is this one here, as I was saying, stores the central locking code. So what I did was I took this IC off the working key, the key that I know that works, this key here. I took the IC off that one and I fitted it onto this board here, okay. And then what I did was I put it on the RF tester, and it fired up straight away. It was giving an RF signal, okay. So that made me think that the chip that was the original chip that was on here, that made me think that that was faulty. And what I did was I managed to track these chips down online from China, and ordered some replacement chips in. I ordered 3 chips in. I thought I'll keep some in stock as well if these jobs come up again. And what I did was when the chips got here, I fitted the chips onto the board, okay, and I was not getting any RF signal when I tested it on the RF tester. So what I did was I thought, okay, what if they've given me a faulty chip? It was a reliable source that I obtained the chips from, because I've bought the RF chips from them before and they were working. So I had no doubt about their reliability. But just in case, I thought, in case if the chip is faulty, I changed it out again with another chip. Same thing again, no RF signal. And I had 1 chip left, so I took it out of the pack and I thought, let me try that one as well. I put that one on and the same thing. They exhibit the same behavior. They do not. Once I put the last chip on, I was not getting an RF signal coming off this board. So again, this is speculation because I have no way to test it any further. But I think what it is, when you install a new IC onto these boards, the IC that stores the central locking codes, I think those chips will not transmit an RF signal until they've been activated. And during the activation, what happens is the code is written to this IC. So I guess what I'm trying to say is, if you're working on one of these fobs and you get to a point where you think, okay, I need to replace this IC, then just replacing it is not going to get it to work. You're going to have to get to somebody who's got a programmer, okay, and who can program that code into that chip, because when you replace this chip with a new one, it's like a brand new key, right? And at this point, it does not have a code stored on it. So that would make sense, because if it doesn't have a code stored on it, then what is it going to transmit? It's got nothing to transmit. So I believe this is what's happening here. I believe that once this chip is replaced, it would have to be programmed in. Now, I'm going to get this back to the customer, and I'm going to ask him to check that out and get back to me. So I'll make a future video and I'll let you know what the update was regarding this IC and whether it worked or not. But for now, I just wanted to give you this new information so you don't start going down an endless rabbit hole, and the experience that we've had, you could possibly learn from that as well. Right, okay, so another thing that I want to do is I'm going to go under the microscope now, and this is for reference for anybody else who comes in the future and is working on these fobs. I'm going to test each and every component on this board, okay, and I'm going to give you the diode mode readings of the ICs as well, and you'll know then if you're ever working on one of these, you can compare the diode mode readings from your key, from your fob, to this fob here that I have here, and you can see if there's any major differences, then obviously that would point towards possibly a faulty component somewhere. So I'll do that for reference, and that will always be here online. You can come back to that and refer to that. So let's do that now. Okay, we've got the PCB for the fob underneath the microscope, and we're going to go down the board and we're going to take the readings of all the components, and then you'll have it for a reference. So here goes. The first thing that we're going to do is we're going to test the continuity on the buttons. So put your multimeter into continuity mode and just test the 2 points here. So I'm touching the 2 points, as you can see, and I'm just going to press the button. So you can see that there's continuity there, 0.1 ohm. That means it's clearly the signal is getting through. And let's test the other button at the bottom, this one here. If we do the same thing, put the multimeter leads on these 2 points here. If I get up here and if I press this button, you can clearly see that it's 0.1 ohms, and that's a clear signal going through with the button press. Okay, so the 2 buttons have been tested, and we can confirm that the 2 buttons are working fine. Let's take the readings for the rest of the components here. So there's a 101 ohm resistor here at the bottom. Let's check the readings on that. So what you want to do is you want to take your red lead and you want to put it on a ground point somewhere on the board, and then use your black lead to take the readings. So let's take the reading at this point here, and it's reading 629 ohms. Let's take it from here, and it's 546. Okay. Then we've got 2 capacitors on the side of it. Let's test those. Here we go. 545 ohms, and the other side is ground. 545 ohms again, and the other side is ground. Then we've got another component up here, which is related to the RF signal. Let's test this one here. So on this side you've got 718 ohms, okay, and on the other side you've got 726 ohms, okay. Then we've got another capacitor on this side here, the big one, the big orange one. Let's test that. So on this side here we're getting 545 ohms, and on the other side we should be getting a ground, and as you can see 0.1 ohms, that's clearly a ground, okay. Then as we move up the board, the next component is here. It's another capacitor, so let's test that one. And this one is giving us a reading of 544 ohms, and the other side should be ground, and it is a ground. And let's test this capacitor here. We've got 566 ohms, and here we've got ground, okay. So there's only one component left to test here, and that is the button. So if the reading on this side of the button should be around 692 ohms, and on this side of the button here should be ground, okay. So that's ground, and that's all the components on the front side of the board. Now let's flip it over and get to the back side, and let's test those components on the other side. Okay, so we've flipped the PCB over, and here are all the components from the top to the bottom. So let's start from the bottom of the board and take the readings for these 2 capacitors here. So here goes. So this side here is 626 ohms, and this side here is open, okay. And you come here again, 626 ohms, and this side here will be again open. So 626 open, and 626 and open, okay. The next component that we're going to check is the resistor here, and the reading on this one, on this side, is 626 ohms, and on this side here the reading is 627 ohms, about 26, 27. Okay, then what we've got here is a capacitor, so let's check that one. So the reading on this one, this side is ground, and on this side here we've got 725 ohms. Okay. Then if you move further up, we've got a resistor here on the top. Let's test that resistor. This side is giving us 718.19 ohms, and the other side is ground. Okay, so we've got through that, and the first IC that we're going to test is this one here, and this is the RF IC. Okay, if you want to find out more detailed information about this, watch the previous video that we made regarding this chip and replacing it. So let's start from pin 1. Okay, so pin 1, we've got a reading of 677 ohms. Okay, pin 2, we've got a reading of 676. Pin 3, 666. Pin 4 is ground. Pin 5 is 725. Pin 6, 1, 2, 3, 4, 5, 6. Pin 6, 716 ohms. Pin 7 is 719 ohms. Okay. Pin 8 is on the bottom here, and that's 724 ohms. Pin 9 is 544 ohms. Pin 10 is 626. Pin 11 is 627. Pin 12 is 544. Pin 13 is 666. And pin 14 is 675. Okay, this is a working chip, right? Now, there's only one IC left to test, and that is the IC 664006, the one that stores the central locking codes. So let's start from pin 1, which is here, and pin 1 is 567 ohms. Pin 2 is ground. Pin 3 is 677 ohms. Pin 4 is 692. Pin 5 is 692. Pin 6 is 692. Pin 7 is 544. And pin 8 is 544 as well. Okay. Then we go 9, 544, 10, 689, 11, 675, 12, 675, 13, 665, 14 is 689, 15 is 544, and 16 is ground. Okay, this is a fully working fob. I've compared the readings to these readings are from a fully working fob, or they're the same as a fully working fob. So if you've got one of these fobs now, you've got all the readings from a fully working fob, and it will give you some initial direction about which route to take for your fault finding. Okay, so as I was saying, this here is the RF chip, and we replaced the RF chip, and we didn't have any success. So what we did then was we replaced this chip here from a working board, and the board fired up and it was working and it was giving off a signal. Okay, so that was a chip that already had a code programmed into it. Then what we did was we bought these chips online, we had them delivered, brand new chips, and we changed them out for the faulty chip that was on this board, and it was not emitting an RF signal. We did that 3 times with 3 different chips, and we were still not getting an RF signal. And we came to the conclusion that just changing the chip out is not going to give an RF signal. What you then have to do is you have to get the chip programmed with the code, or the code programmed into the chip, and then it will emit an RF signal. And again, this is just speculation based on the testing that we've done. we do not do car key code programming, so there's no way we can test this any further. If there's anybody who watches this video and who's much more knowledgeable than myself regarding these fobs, then I'll be very grateful if you could leave a comment down below and share your guidance and your knowledge with us, as I'm always learning and I'm always willing to learn. Well, that's it for today's video. We're going to wrap it up now, and what I'll do is I'll get this fob back to the customer, and I'll make a future video where I'll give you an update on whether they were able to program that code in to the IC and get the fob to work with the vehicle. I hope somebody found this information helpful, and if you did, then please do share it with others. So as usual and as always, bye for now and have a nice day.